Hello, mathematicians. Okay, so in lesson 1 and 2, you learned how to solve equations. And so now what we're going to do is we're going to look at some equations that when you solve them, you get kind of funny looking answers. And so we'll talk about those. We call them no solution and infinite solutions, which I always say infinitely many. So you'll hear me say that a lot in class. Okay, so let's go ahead and take a look at our first problem. Notice that I do have to simplify first. So I do have to start with my distributive property. I have negative 4 times a positive 2x is going to be negative 8x. Negative 4 times a positive 1 is negative 4. Then on the other side I have a negative 8x minus 2. Now as I start to solve this, I notice that I have variables on both sides. I'm going to have to bring my variables together, but they are on different sides of the equal sign. So I have to move them by either adding or subtracting. So I do want to make this a 0. So I am going to add 8x and add 8x. As soon as I add 8x to both sides and I rewrite, I notice that I get this funny equation that says negative 4 is equal to negative 2. Now, that is not a possible answer because negative 4 is never equal to negative 2. So I'm going to put a big slash across the equal sign, and I'm going to say that this has no solution. That's because when we solve it, there is no way that the solution can work. So that is it. Now, the second one that we have is an infinitely many solutions. Again, I do have distributive property to do, so I'm going to go ahead and distribute this 3. I'm left with negative 5 minus 9x equals 3 times 1 is 3. 3 times negative 3 is negative 9, and I have that x. And then I have a negative 8. Don't forget that negative 8 is hanging on there at the end. Now I do have to bring together my like terms. Notice that I have a 3 and a negative 8. So when I rewrite this, I'm going to bring those two together. So as I rewrite, I have negative 5 minus 9x equals, when I have this, negative 9x, and I bring 3 and negative 8 together, I get a negative 5. Oh, that's interesting. I think I see the same terms on both sides. Let's go ahead and start to simplify and see what happens. Okay, now notice that I have x's on both sides, so I need to move 1 to the other side by either adding or subtracting. So I'm going to add 9x. That actually becomes 0. Whatever you do to one side, you do to the other. I'm going to add 9x. And again, that becomes a 0. So now as I rewrite, I'm left with negative 5 is equal to negative 5, which is true. But notice that if I add 5 to each side, I'm now down to 0 equals 0. And what this means is that all solutions work. That is, when we get into systems of equations, we'll talk about how this looks on a graph. But no matter what solution we sub in for one, it will work for the other. So as you go to solve these problems down here today, you're going to find that some do have one solution where x equals something, but then you're going to find some have no solution, and you write no solution, and some will have infinite solutions. When it's infinite solutions, we actually draw this cool figure 8 that's on the side. This means infinite solutions. Okay, I will do one more here, and then I will let you complete the worksheet on your own. Okay, here we go. 3 times 2x, 3 times 2. So I get 6x plus 2. Don't forget that negative 3x there. On the other side of the equal sign, we have a 6 plus a 3x. Okay, see, I got some terms I have to bring together. I've got a 3x, negative 3x, and a positive 6x. When I bring those together, I have a 3x plus 2. On this side, I have a 3x plus 6. I wanted to see what they look like together, so that's why I brought them together. Okay, so now I do have to move my 3x, because I have x's on both sides. Minus 3x, notice that becomes a 0. And as soon as I subtract 3x from the other side, up, I've got another 0. So I've got that funny looking equation that says 2 is the same thing as 6. which we know is not true. So this is a no solution. Okay, go ahead and keep working, and there is practice also in Delta Math.
Not that one.